What is the universe made up of? This question has been asked by humans since time immemorial. Starting from the age of ancient Greeks, Indian and Chinese philosophers, all the way to modern scientists, everyone seems to be asking the same question. As our technology has grown over the last 2000 years, our ability to answer this question has also increased. By the end of 1800s, the scientists had a pretty clear idea that the universe is made up of two things. One is called matter. Matter is all that we can physically see in this universe, be it solids, liquids, or gases, living or dead, organic or inorganic. All of these objects fall in the category called matter. Matter has a special feature that if you break it down, you'll observe that it is made up of particles. Take, for example, a stone. If you were to crush a stone, you'll observe that it breaks down into dust particles. If you were to look at waves constituting water, at a fundamental level, they're made up of droplets. Gas is made up of gas particles, so on and so forth. The second class of objects that constitute our universe are called interaction fields. Two particles constituting matter interact with each other, and these interactions happen through fields. A very simple example is gravity. Two objects with a certain mass interact with each other due to their mass. Similarly, there is electric and magnetic fields. Light is another field. So these two classes of objects constitute the entire universe. Be it the Earth, be it the sun, be it stars, or galaxies far away, all of them are fundamentally constituted either of matter or of waves. At the end of that age, scientists thought they knew everything. But like always, there is a catch. Early experiments in 1900s showed that if you were to zoom into matter or fields, they behave very differently. They observed that electrons, which are particles, started bending around objects, showed superposition principle and interference patterns, very much like light. When they started looking at light at extremely dim intensities, they observed that light comes in chunks and units, just like particles do. These results showed that matter behaves like waves and fields behave like particles. This completely changed the perspective of what we understood about the universe. Well, so what's the use of studying such small objects? Imagine, what if you could control at the microscopic scale all of matter? What if you can create objects that are, instead of being localized like particles, smear around like waves? What if you could create objects that could tunnel across barriers, just like sound wave goes across walls? With quantum physics in place, nothing is impossible.